I'm going to get started. It's 1:15, so welcome. And thank you for your interest in this project. I don't know how well it fits the overall theme of the conference. So I want to show you a prototype of a Godot multiplayer game that is actually a translation of a location-based educational game called Operation Outbreak, which actually you can try now if you want. I wanted to start with that. If you go to the App Store, if you want, it's completely optional. While we have this conversation, you're welcome to install the Operation Outbreak app that you can find on the App Store and actually join a simulation that will be this group of people here during 15 minutes. If you want, it's optional, you know, like as another fun thing to do. And I want to show you something. I'll show more about this at the end, but you see here that there's a join code that you need. I just set this up now, GodotCon 25. So those of you who install the app, when you open the app, you will be asked for a join code. So just install that, and then forget about the app. It will spread a virus, by the way, a digital virus. So, but you don't need to do it, okay? The app doesn't collect any personal information, by the way, but if you want to do it, at the end we can look at the data, okay? Again, the code is GodotCon 25. All right, so going back to what I want to talk about today is how we make this game that some of you might try out on your phones into a multiplayer game with Godot, and why we want to do that. So this is a project that I've been conducting with two very talented Godot developers, Harmony Monroe and Facundo Fernandez, who unfortunately they couldn't make it here, but speaking for the three of us. I'm going to start with some animation there. See, I think it's very fitting because the Godot mascot is running away from the viruses. It actually works. So, just very quick introductions myself. I'm an assistant professor of genomics and computational biology, so what I'm doing here, maybe it makes sense, at the University of Massachusetts Medical School. I don't know if this rings any bells. For many years, I was a contributor to the processing project. I don't know if you guys are familiar with it. Okay. So, Harmony Monroe and Facundo Fernandez are, as I mentioned, very talented indie Godot game developers, and you can check their work following those links. And that's about that. Sorry, forget about this. The initial kind of idea of making this into a Godot game comes from Lena Diaz, who's a CS graduate student from Worcester Polytechnic Institute in Worcester, not far from here, around 1 hour drive from Boston, who implemented the very first prototype of this Godot implementation of Operation Outbreak. So, what is Operation Outbreak? I guess it's fitting that I talk a little about this project. It's a platform for science education primarily that uses a mobile app that some of you might be running on your phones that simulates an epidemic process through Bluetooth, essentially. By sensing proximity between people, it will determine transmissions using some mathematics inside of the app. So this is an app that allows these kind of very immersive type of location-based or real-life simulations of disease transmission. We have worked in many schools in the US and abroad for more than 5 years, actually 6 or 7 years since we started with this project, which again has a very strong motivation in science education. These are some images of an early version. So these are middle school students using a very early version of the app, and again, it's running away from all the viruses. What was the motivation of this project? I would say that the first motivation from the team who really is driving this project nowadays is to how to educate students about infectious diseases in more engaging ways. Right? I think a very important topic, especially after going through a pandemic. Right? And another motivation, which is more my own motivation as a scientist, I guess, is to generate data with which we can use to understand disease transmission in different ways. I won't go into the details of that, but I think it's important that we have these tools to generate data. And the answer to these questions, how we do these two things, is, well, let's run these real-life simulations. A little bit of kind of the motivation, these two questions, and the answer is, let's do these outbreak simulations in real life. It's not really a new idea. You might be familiar with some of these board games or app games. People have used outbreak simulations also as training for epidemiologists. That's a paper in the bottom about how to use kind of mock outbreaks to educate people, epidemiologists specifically. And this is even with the use of mobile apps, is something that people have tried before. This is, you can tell from the appearance of the phone that this is from, pre-smartphone era, right? And this is the idea of this project was to collect network data, how people interact with each other by using the Bluetooth sensing, and with that understanding patterns of transmission based on that data. And anyone, anyone is familiar with this? Yeah. This is a famous incident, the corrupted blood incident that happened in World of Warcraft already a while ago, right? Like 20 years ago, where there was a bug in the game that created an epidemic process, like kind of a virus-like transmission that killed a lot of players. And people actually wrote papers about this. This is a research paper about that, and how epidemiologists realized that players behave in surprisingly realistic ways while dealing with this virtual outbreak, even though it was just a virtual situation, no risk of death or of real death, at least. So this is also part of our motivations for this project. The origin of this goes back to a middle school in Florida where a civics teacher had this idea of doing mock outbreaks with students. He would hand a pile of stickers to the index case, and that person would start. It was more like a tags game, if you think about it, right? And it was very dramatic because I think that what made this very fun for kids was, okay, we have all these paraphernalia. It's like a very performatic kind of thing, right? It's really like a like a very immersive experience, and they even got like PPEs. This was before COVID, okay? This was pre-COVID. So maybe at that time was fun to play about outbreaks. Then not anymore. And they had to report symptoms. It was a way of teaching public health in an immersive and engaging way. And some kids would play the different roles, like government, epidemiologists, etc. And then what we did, or kind of my contribution to the project, was when I was at the Broad Institute, which is a research institute just down the street, just a few blocks from here, one block from here. I learned about this project, about this very fun simulation in this middle school in Florida, and I suggested, since I had this interest in digital technologies, why don't we make it into, the transmission instead of being like with a paper tag, why don't we make an app that uses Bluetooth to spread this virus, because that would make it more realistic. And that's how the project, at least this version of the project started. And you see that this diagram at the top is something I put together like before making the app, and then this is a very early version of the app that I can play briefly, but what you have now is the latest version of the app that is much more advanced, but this is something that it still operates in very much the same way. You enter a code, and then once you enter a code, you are in this simulation, and the app would compute proximity between players and kind of, in a way, enable the spread of this. This is all logo. But anyways, I think you get the idea. So I'm gonna move on. This is a kind of when we ran the first simulation in this middle school, around 200 students, and yeah, it was a lot of fun back then. We even wrote an opinion piece with the rest of the co-creators of the project. This was kind of 2019. Why wait for a pandemic to respond, and making the argument that these type of simulations could be helpful to prepare and to educate people. So why wait for a pandemic, right? And we wrote that like March 13th. Just wait 1 year and we have a, you know the rest of the story, right? So what we ended up doing, even during the pandemic, which made it very difficult because this is a proximity-based game, you cannot really play it if you're not with people like we are now. But this was difficult in 2020, 21, right? But we managed to develop this, and we created a whole infrastructure to do this, kind of to allow these simulations in schools, and even to generate data, which you can see here. There are publications about this. You can check. You can find more information about the project on that site. And how this connects with Godot? Well, I'll get eventually get there. But this also, I guess, hopefully, is interesting for you to see the story of the project. And they have evolved quite substantially over the years, working with very talented information and UX designers. Here you see kind of how the app operates with the different states. The different kind of states when you start from asymptomatic or healthy, and then it goes across different states depending on what happens during the outbreak, etc. So this is kind of a little bit of an intro about the app. The app is also quite, there are things that we cannot test now, like using QR codes to do things like masks, vaccines, etc., rapid tests, even quizzes, etc., etc., etc. So what is this? Oh, and this I also want to mention another very cool aspect of the project, which is the visualization part, which this is done by Founder Information Design, which is a data visualization information design studio, which is actually across the bridge, just also very close to here. And they developed these very cool tools to actually visualize the data. So each dot, okay, this was very short, right? But I think you got. So each dot is a person playing the game, with the app, and it shows the contacts between people and how the red dots are people who got infected, and the other color represents other states. Okay, so this is how you can actually use the data in different ways to visualize and to do analysis. Okay, so we built all this big infrastructure. Okay. Next. Okay, it's a pretty fairly comprehensive and robust infrastructure with an app client, which is the app that some of you are using, a data backend, and a series of web tools to configure simulations to visualize the data. Okay, so why we want to make Operation Outbreak? So given that we have all of this already and lots of schools are using, why we want to make it into a multiplayer game, I guess, a question we can be making ourselves. A simple answer could be just because it's cool, right? Let's go back to World of Warcraft, right? Because World of Warcraft was actually a multiplayer game, right? Where you have an unplanned outbreak. But I think the motivation originally started, even this kind of goes back to the first day, to the kind of the pandemic days where, okay, we have this outbreak game that we need to play in person, but we can't because schools are closed. So let's try to make a version that could allow us to do that remotely, right? So that was a first motivation. Nowadays, there is also the issue that this is a whole separate discussion whether or not students in middle and high school should be allowed to use their smartphones because it's distracting, and some states are taking, they want to limit the use of smartphones by students when they're at school. That might also might make it difficult for our app version of the game to be used in schools if students cannot use smartphones. I guess we can also prototype things easier in a multiplayer game than doing things with the app that requires a whole setup with people and in a physical space. And this is, to me, I put like this underline is because we can do experimental games to study disease transmission and in a way that we can scale potentially to a much larger group of participants, right? And what else? We can also try things that would be difficult to study in real life, to implement as game scenarios. And then we could replicate corrupted blood incident, right? Going back to the origins. So how we did this, and there is a lot of interesting ideas in kind of behavioral research about how we can use video games to understand human behavior. And there is this is a paper that was published last year about that. So again, I just want to leave it as a quick comment that we could spend a whole hour just talking about this, right? But maybe more important here is how we made this, right? And so we have this infrastructure, which essentially we have a backend for the Operation Outbreak data, we have a client, which is a mobile app at this point, and then we have a set of tools. And yes, the client is the app. Now, what we want to replace, essentially what we are doing here is to replace this client by, we're replacing the mobile app client by a Godot client that kind of replicates or kind of provides a virtual environment to play the game. And we also have a game server that simulates, kind of replicates the physics, because we have the physics for free in the mobile app game, right? We don't need to calculate the physics in the real world. So we need to calculate that. So essentially, we made these two components. We prototyped these two components. The cool thing about, or kind of the great thing about this is that we can reuse the rest. Essentially, to run these multiplayer simulations with the Godot client, we don't need to change any of the existing backend, I mean, the visualization tools, because we made the Godot prototype compatible with all that already exists. So kind of the data looks the same way when you look at it using the visualization tool that I showed you before that displays the data from the app. It's the same thing, because the kind of the game in the virtual space that now we have with Godot generates exactly the same type of events that we then use for analysis and visualization. So that, in a way, allows us to reuse all of that infrastructure. So I guess what we have to do is to, well, these slides are not particularly polished because I just, I ended up doing part of these slides kind of this morning, so I apologize for that. But I just want to I'm getting a little more in the technical details, just jumping right into this. Like we have a user flow, you saw that you have to enter a join code, and by enter the join code, okay, the existing API will send the client simulation parameters, which tells the client how to run the simulation. This is what happens in the mobile app, but what we are doing essentially is replicating this in Godot. So all these endpoints already exist. So what we want to do is to essentially reuse all of these to kind of replicate how the app works. And I won't go into the details of these parameters, how they work. There is a lot of information that we need to use to run the simulations, how infectious the digital pathogen is, how long the infectious state lasts. For all of these are parameters that the app receives, the mobile app, and now the Godot game. By reusing existing API, we have all of that already implemented. What else there is here? Yes, I mean, there is a simulation loop. This is essentially a number of what is the logic when people join a simulation? You need to infect a few index cases randomly, right? To start the outbreak. We have some algorithm in the app which does that based on how many cases are already going. Actually, this is easier to do with the virtual game because it's kind of hard to do with the mobile app, but it's much easier in the Godot game because we have absolute control of the physics of the space. We simulate the space. In the real world, we need to kind of figure out what happens in the space, which is harder, actually. Well, I guess some things are harder, some things easier, I don't know. Well, there is also, as you can imagine, there is, we need to detect what happens in the game world, right? And the basic thing we need to know is when two users or two players come into proximity with each other. In a mobile app, it's based on the Bluetooth signal. The stronger the Bluetooth signal, you know that the closer people are, which can be tricky because Bluetooth is kind of not very, I mean, it's affected by all kind of noise and things like that. And some phones have poor Bluetooth connectivity, so all of that makes it very hard. But and so essentially, you need to keep track of who you're in contact with, and removing players who were next to you when they're not already in contact. And this is actually something that, well, this proximity. I mean, when we do it in Godot, it's essentially calculating distances between all players, which can be done in very efficient ways. And I'll talk a little bit about that. But yes, I think there is this situation where, okay, one player is infected, or user, and then you need to calculate probability of infection. Again, all of that is already given in the parameters we have in the Operation Outbreak backend. And then we have to do like a progression of I don't know if And if you have the app running and you already see some changes in the app, but you have to simulate the different states in the progression of the disease. So all of this is what kind of we implemented in the client. Let's see. So this is what happens with all of that I just explained is I didn't really made any of that. I mean, I guess I had to get people who know how to, develop games in Godot, essentially. And like a couple of months ago, I reached out after the first prototype that this student made. I went to the forum and said, hey, we have this project that we want to, get going, create at least a prototype, and that's how Harmony and Facundo came on. And I have this video from Harmony showing how he developed essentially the division of tasks we had in our project is Harmony kind of created this prototype UI for the game, and Facundo created the server that does the physics simulation. Okay, so Harmony just made this video last night, so I didn't even watch it. So I'll just play it. It's 12 minutes, so I think we should have enough time because I don't have much more. Let's see. Oh, I don't know if we can hear this. Because I have the sound. Can you hear? No.
Outbreak.
Back in the back.
Of course, this started on one of the Godot forums. I saw a job listing post that I replied to.
Okay.
An online multiplayer educational game. And in a couple days, I put together this prototype called Skate Chat. That is a online multiplayer game using Silent Wolf to synchronize data between everyone. You can pretty much skate in a circle, skate around some cones, and chat with other players. And I emailed this to Andrés Colubri, who responded to me and said, let's work together. We also worked with Facundo Fernandez. So this next video here is the beginning of the project. And
so you guys in the back can hear the audio? Yes? Okay. Just wanted to.
I was met with this GitHub repository with a folder in it called Code from Lena, or Lena as it's pronounced. So Lena built this foundation for what we were working with here.
It's nice because it's showing the whole history of how we made it. So I'm watching this video for the first time. I really didn't watch. He told me, okay, I made this video for you to present at the conference.
You see, every great project starts with a Godot icon. I went ahead and replaced that with these faces here to get some character going and see what happens if we have collision between these characters. Eventually I decided collision is not necessary. And I was also working on a 2.5D version of Skate Chat using this marionette puppet character sort of vibe with these images. Everything here is made out of Polygon 2Ds and Line 2D nodes from the Godot engine. And it rotates in such a way that it looks like a 3D image. I am using the X and Y coordinate with a node parent, and then it's offset on another Y coordinate, so it's faking the Z axis in this case. You can move everything around on these 3 different dimensions, and then when you rotate them in a specific way, you get this effect, 2.5D stacked sprite effect, as some people call it. So I used this same puppet design, and I added elbows and knee joints, and I removed the skateboard. And after that, I added this walking animation, which is pretty simple. There's also an infection stat that would change the color of the player. You can see here we got some art coming. There's a doorway and some buildings, and this character can move around in the world. So in this clip, we have the animation synchronizing between the 4 clients. When you're walking, you can see your animation, and you can see the animation of other online players walking around. There's also different colors being synchronized. And here we have a chat window going on. Now we have players infecting each other, so you get close to someone who is green or yellow, and they'll turn red with the red virus. Turn back to green. They turn this person back to green as well, and you see they don't infect each other, but this red person will infect them. The ring now changes colors when you're in contact with another player. We ended up removing this ring for playing. It's just a debugging visualization this update I added colliding with buildings. You can walk into the doorway of something, but you cannot walk around the edges, and that entrance doorway has no collision at the moment. I'm really just testing it with these simple polygon buildings, so you can walk inside the door frame. That's about as far as you can go. Here we're showing off the code to join a specific instance of the game, because you want to join whatever classroom of students you're playing with. So in this case, the code is test. If you type in something else, it won't do much. And now we have the chat box working. Whatever you type will be visible to other players in the chat box as well. In this update, I added some street assets, a little park here, make it a little bit looking more like a town to flesh out the world a bit. This is when I added the mask to the player. You can see if I unclick the content and rotate the character, the mask actually exists outside of the face. But when you click the content, it looks like it's a part of a 3D texture almost, although it's just 2D and just rotating around that center axis. Now we have implemented some items. There's simple text on top of it showing quiz item, test item, mask item, vaccine item, food item, etc. You can pick up items, and when you pick up a mask, it will actually change your player from having a mouth that's uncovered to a mask uncovering your mouth, and it will reflect online as well. So now we've implemented the icons from the mobile phone game and put them into this version, so you can see the mask, vaccine, test, quiz icons, and the food apple icon. You can pick those up, but you can't see where it goes yet. And on this instance, we're showing that picking up items is client side, so if another player picks up an item, it won't be removed from your world. You also have an opportunity to pick up that item. And everything has to start somewhere, so this inventory display is just some simple text on the screen that says inventory display. So this actually, you can see the mask gets picked up, the quiz gets picked up, the vax gets picked up, and it has these counters in the bottom left corner showing how many of each item you have. In this video, we're seeing that the health status icon from the mobile app is now in the bottom left corner where it shows healthy, sick, very sick, recovered, with a little squiggly icon. And now the inventory display is in the bottom center of the screen. There's also these little sickness, contagious particles that show. Yellow if you're mildly sick, red if you're very sick. It's emitting these particles around you, common germs. You can also die from this and be an invisible character like this. We also took the ring out because the ring was just for debugging purposes, and we don't need players to see when they're in contact with others. So in this update, I made a little debug menu that will toggle the ring for testing purposes. We can see if players are making contact or not. It's not something we want to be visible in the final game, so we can turn it off. In this update, you can see the text is now appearing over players' heads, and every player is also assigned a random color at the start. We've done away with the green is healthy, red is sick color. We want it to be more ambiguous as to who around you is sick and who is healthy. So now the synchronization of contagious effects and visual health is working, which means that whatever health status you have or contagion status you have on the client side is being reflected on the server side, so other players can see your contagious germs. And this update is pretty silly, but item inventory display was not working on the online clients. It was only working on the hosts, so now it works across all clients. Everyone can see what items they have picked up. In this update, we have a server and 3 clients, so the server is running an instance of the game that does not have a player, and then there are 3 clients that can connect to that server instance. We'll have to ask Kondo more about this. He is responsible for the server-side code and multiplayer. In this update, we have a username that now shows under each player walking around, so whatever you set your username to be will be visible in the game world. This person's name is I am cool, the other person's name is so am I, and the last person to join is I'm less cool, sorry. You can see their names under each player. This update has a little debug menu where instead of using random key lines assigned by me, you can interact with this user interface to debug the game, and that means changing your contagion giant 17-minute video. You can see the map looks a lot different here. I spent a whole giant night up late putting this map together for this test here because we wanted a convincing video to show to the rest of the UMass Chan Medical School to be see if this game is worthy of getting more funding and continuing the project. We did about 2 months of work at this point, and once we showed them this video, we got approved for about another month's worth of work on the project. So this is the simplest online prototype we put together where players can join a world, chat together, pick up items, and infect one another. And there's a giant map to walk around with 2 parks, a few streets, and some hidden items all around the corners. And now the character customization comes into play. Here I am changing the properties in the Godot editor to make a player have specific colors to customize your character. So there's a group of different nodes that have a color assigned, and when you change the color of one of these properties, it will assign a modulate property to all of the nodes in that group. And here we have the character creator working in the game itself. I was a bit inspired by the old school RuneScape character creator with some left and right edges to change what your player looks like. There's a hat, hair, face, eye, shirt, hands, pants, and feet color can all be changed. There is a preset palette of colors to choose from. Just click left and right and see what looks best on your character. You can change your clothes at any time, clicking the change clothes button on the top left. There's also a randomization button, and I feel like every good game has a character creator. It's nice to express yourself in your digital avatar and be able to tell one player apart from another. So putting this character creator in was something I wanted to do from the beginning, and I'm glad that I got it in there. And after that character creator, I started doing some revisions to the UI based on Andrés' feedback. So there is a hunger meter and there is a mask meter, which means after a while you'll get hungry, you gotta eat more food, and after a while your mask will wear off, you have to get a new mask. There's also a readout for your testing status, whether you tested positive or tested negative, and how long it's been since that last test. So in a minute it will show that. There's also a list of symptoms you're experiencing, and there is a money counter to be set in a shop that we're yet to implement. This is about as far as we've come on Operation Outbreak. Hopefully we can continue to work on this in the future. There is plenty of educational budget cuts that are holding us back at the moment, so hopefully we can find some more funding and put some more effort into this project. It's been a lot of fun making it. Thank you to Andrés Colubri and Andrés for collaborating on this, and thank you to Godot Engine for making this so easy to do. And if you're watching this on the stage at Godot Conference, thank you for attending. Sorry I wasn't able to make it in Boston today. Goodbye from Baltimore, and enjoy yourselves.
I'll let Harmony know that his video went very well. It's amazing. He showed the whole process. As I said, I didn't watch the video. I actually didn't have the time, but he kind of gave a very nice rundown of how the process went. So I'm gonna end. I mean, I don't have much more. I know that we have time until 2, right? 2. So let me go back to my slides.
Hello.
Oh, no. Sorry, Harmony. No, wait, I need to put it here. Yeah, I just want to. Then we have this client-server architecture where essentially, if you do a game like this where you won't need to calculate interaction between players, you can do it peer-to-peer or have a centralized authority, kind of centralized server, right? There are 2 approaches to do it. So we went to the kind of the client-server architecture where there is a authoritative Godot headless server that kind of handles all the kind of the game state in terms of where players are and who is in contact with who, and also prevents cheating or desync. I'm not sure what it is, but this is kind of, since we have this kind of central server, this simplifies physics and logic, I think. This was Facundo's work, right? And he has been testing it. Since that scales very nicely to have games with lots of users. And disadvantages, I guess, we need an additional infrastructure for hosting this server, right? And this some extra latency. So, yes, I mean, I cannot show this. I wanted to do a live demo, but I don't think I have time to show how we spin this kind of game server with a Docker container. But I think you get an idea of how it runs. And yeah, I think this is what we hopefully use to keep building out this new infrastructure. So next steps, I guess there are multiple directions here because this project has been evolving in different directions. There is the educational kind of the original educational emphasis of the project, which now I'm less involved in, but it's still very interesting and very important. And I think we could try running games that replicate what people do in the physical version of the game, but now in this virtual environment, right? I'm interested in how we could take this whole prototype game to maybe try new scenarios and investigate specific questions. Whether what people choose to do in a given outbreak situation, but that's something that we need to kind of keep fleshing out. So what else? I think the project, not the game, which kind of this game that Harmony explained very well, but the Operation Outbreak project, again, you can go to the operationnourbreak.org and read more about how the project came about and all the people who were involved in it. We had funding over the years, especially for the app-based platform. This is kind of branching out from the Operation Outbreak, the original Operation Outbreak project. And yes, I mean, this has, this is, well, here is missing Godot. What happens is a slide I took from the original presentation of Operation Outbreak that is only about the mobile app. And this is the kind of the technology framework we still use for the proximity sensing. So Herald is a Bluetooth, it's a proximity sensing library for mobile phones, actually. And yeah, I think thank you for your attention. I want to leave a little short time if people have questions. We can talk about this. Well, we can look also at what happened with the app. I don't know how many of you installed the app. And of course, I'm happy to talk more about this project if any of you is interested. That's my email. And yeah, thank you. So this is, let me show you a little bit. Okay, this is the kind of the creator tool, which the simulation is still running. It's 50 minutes, and I set up this. It's gonna end very soon, like in 5-6 minutes, because I put it. I think it's gonna be. Actually, I started at 1:15, so it's gonna be like. Yeah. We can look. I mean, the thing is, we can look at the data now. Oh, yeah, I think you can still join, but it's about to end. I don't know if anyone joined, but you have. Well, I didn't show this. You can scan this QR code if you want, and you can get a mask or a diagnostic test. And you saw in Harmony's video how we've been trying to replicate these functions in the virtual environment, right? We do it by picking up items. I guess that's probably the easiest way. I can actually infect people randomly. If I press this button, it's like it sends a push notification that is invisible to the app. If you use the app, but it will trigger an index case. So, and I think if I go to the dashboard, I should be able to see the data, or it should be a point where I can actually see the data. I don't see that. I think it shows. Anyway, in a few minutes we will be able to see what happened in this kind of simulation. Oh, not the visualizer. Oh yes, but there were no cases. Actually, no one got infected. Okay, great. But well, I mean, not much happens because we are just sitting in this node. I mean, the position of the dots doesn't reflect location. It's just a random network visualization. It's not, because the app doesn't collect GPS location. So it just plays dots based on who is in contact with whom. Anyways, so no infection, that's weird. Maybe I did something wrong. I set this up, I just thought of doing this 1 minute before starting the talk. So I don't know if I set up things correct, but anyways. Oh yes, this one index case here, maybe when just now, because when I did push infection, someone got infected just now when I pushed the button. Anyways, the cool thing is that this same interface will work if we run the Godot game, because it will use the same backend to save the data. All right, so we have a few minutes. Yes.
I have some questions about the multiplayer backend part of it. I don't know if you can answer them, but you use Silent Wolf for part of it, and then you also said there was Docker containers,
yes,
and they were self-scaling.
Yeah.
Are those all does Silent Wolf provide all of that, or is that?
No, I think okay. The hosting, Facundo has his own hosting service. So he set that up. I mean, he didn't want to present, or didn't want to. He's kind of shy, so he didn't want to. He told me, okay, show these slides, and I can show you. Okay, I can show you something though. It's like a shout out to his work. Let me see. I mean, it was really, really cool to work on this project because, and I started to learn a little bit of. I mean, even though Harmony and Facundo did all the development, at some moment I did code reviews with them. I started to understand how Godot worked, and I think I should be able to do something myself if I had the time. That's the other problem. But I think it looked pretty easy to get started with. But I mean, I want to show you something. Okay, I have some information on Discord, but Discord is updating, so give me a second. So someone else have a question?
Do you mind talking a little bit about how the mobile app actually fits into the physical role-playing experience? Like, what do kids do when their status changes on the phone?
Oh, there's a whole other dimension of this game, which is they play these different roles to learn about public health, about epidemiology, so they do different things. One version of the game is more passive. You don't do much. You just let the app run, and then at the end, you see, based on how people move around, you can see who got infected, who did not. But the full enhanced version of the simulation with the app is really very active because there's even money that you have to use to buy items. There is stations where the kids playing the government, they are at the station where they have a version of the dashboard that they use to manage resources. Another station is for the kids playing the epidemiologists where they collect the data that, and it's quite involved. I didn't show any of that. But it's really a very immersive type of activity. The app essentially is just the medium through which spread this pathogen. But then there is a whole other dimension that is outside of the app. So what I wanted to show is here. Any other question? Oh, yes.
Just a question, and I have another more in-depth one. What are the different colors of the dots? Is this like susceptible?
Yeah, I think this is green is healthy, infected, recovered, dead.
Well, no, I mean, within the groups.
Oh, yeah, if you're wearing a mask or you have a vaccine, it also indicates whether you have one of these items. So so going back to the infrastructure, Facundo has this thing that is pretty neat. Let me show you. He has this kind of admin thing. Oh yes, so now I can actually. He created this. He has a company. Shout out to Facundo's company where he hosts cloud services, and he kind of very kindly agreed to host this a pilot version of the Operation Outbreak server, or the Godot server, because, yeah, so here I think I could set up a server, kind of this is the Godot server that would simulate the simulation world. And then each user will be running the client, right? But this is, I cannot give you more technical details. I would need to ask. Sorry about that. Yeah, I think there are many interesting possibilities using all of what we've done so far. And yeah, I just wanted to share this with you. Hopefully you found this interesting. Thank you.